Hey everyone! In this tutorial, I'm going to walk you through a model workflow in ArcGIS Pro that automatically updates incident records, performs a spatial join to assign geographic fields like beat, zone, or neighborhood, and exports the final table to Excel for use in PowerBI. So here's the issue. Many RMS or CAD systems don't include a spatial field like Beat 1, District C, or Downtown in their reports. That means that when analysts or decision makers are reviewing visualizations in Power BI, you can't use a simple drop-down slicer to filter by area. Now sure, you could use lasso tools on a map in Power BI, but most end users prefer drop-downs or clean visuals tied to fields like neighborhood or zone. So that's where the workflow comes in. So let's start by looking at how I pulled data from my mock RMS system using Microsoft Access. In this example, I've created a linked table from an external file. You'll notice it's linked by the Excel icon here. Now, I want to map only a subset of incidents, so I'm building a query using the Query Design tool. I'm pulling all fields from the incident table and applying a date parameter. Now, if you're working for a law enforcement agency, this might be dynamic, something like now minus 1095 to pull the past 3 years. But for this demo, I'm limiting it to just April 1st through April 3rd of 2025 to work with a smaller sample. Then I'm turning this into a make table query. So when it runs, it'll generate a new table called incidents table in the current Access database. And then once that's done, I'll save the Access file and switch over to ArcGIS Pro. In ArcGIS Pro, I'm going to create a connection to the Access database we just built. From the Insert tab, I'm going to Connections, selecting a new OLE-DB connection, and choosing the Microsoft Office 12.0 Access Database Engine. Next, I can browse to my Access file, test the connection, and then once it succeeds, I hit OK. I'll include a link to download the Microsoft Access driver in my post. Now I'm back to my map view. From the catalog pane, I'm going to navigate to the OLE-DB connection, expand it, and bring in that incidents table. To visualize these records, I'll use the XY table to point tool. My input table is incidents table, and I'll let ArcGIS name the output for now. Once I hit OK, you'll see the points appear on the map. These are some sample incidents from Cincinnati, Ohio. Next, I'm adding a polygon layer that represents the boundaries we want to slice on in Power BI. In this case, I'm using the Cincinnati Community Council boundaries, which I've downloaded from the city's open data portal. Now I have both my incident points and boundary polygons loaded. The next step is to join the Community Council areas to each incident record. To do that, I'll open the Geoprocessing toolbox and search for the Spatial Join tool. Now in this Spatial Join tool, the target features are the incident points, and the join features are the Community Council polygons. I'll go ahead and keep the default options here for name as well. And within the fields list, I'm going to eliminate some of the miscellaneous fields from the Community Council boundaries file that I don't need, but I'm going to make sure to leave neighborhood name. After the tool runs, each incident will have this attribute attached, and I can preview this by opening the attribute table. This field could now be used to filter in Power BI. As you just saw, this process was entirely manual, and doing that every day could get tedious very quickly. So that's why I always recommend this rule of thumb. If you're repeating a process on a routine basis, it should be automated. So let's move into the next section of the tutorial, the ArcGIS Pro Model Builder. To get started, I'm going to go to the Analysis tab and select Model Builder. This opens a visual workflow environment where we can chain together tools and data to build a repeatable process. The model we're going to build includes 4 key tools. First, I'm adding the Delete Rows tool. This ensures that each time the model runs, we start with a clean slate by deleting the previously mapped incidents. For the input rows, I'm selecting the Incidents Table XY Table to Point layer, the same one we generated earlier using the XY Table to Point tool. Next, I'm going to add the Update Features tool. This tool allows us to bring in the latest data. My input table is the standalone incidence table that comes in from Access. And then target features are again the XY table to point layer. So far, we're deleting the old data, then updating the layer with the new incident records. Third, I'm adding the Spatial join tool. The setup is the same as when we ran it manually. Incident points as the target features and community council boundaries as the join features. Now that it's in the model, all of the parameters are saved, and this step will run automatically each time we run the model. Finally, I'm adding the Table to Excel tool. This will export the final, joined table to an Excel file. As you can see here, I've already set the output path to a file on my desktop called incidenceoutput.xlsx. Now that all 4 tools are added, I'm going to arrange the model layout for clarity. I'll also set preconditions to define the flow, so delete rows must run before update features, and update features must run before spatial join. Once that's done, I'll save the model, give it a name, validate it, and go ahead and run it. To verify everything worked, I'm going to open up the Excel file. And there it is, our incident records, now complete with neighborhood information for each record. This is exactly what we need to build drop-down filters or area-specific reports in Power BI. Here's the beauty of this workflow. In the future, to bring in new data, I simply update the Access query. For this example, I'm expanding the date range to include a few more dates. If your date range was already dynamic, this would not be necessary. Then, I'm going to open up ArcGIS Pro, launch the model, validate it, and hit Run. Once the model completes, I can then go back to that Excel file again, and just like that, it contains the new incident data spatially joined and ready to go. If your Power BI dashboard is built off of this Excel file, the only thing you need to do is refresh the data, and it will reflect the latest records. This is just one example of how we can bridge gaps in CAD or RMS exports using spatial tools and a bit of automation. Thanks for watching and happy analyzing.